Okay, so hello everyone. Welcome to my talk about what going cloud native taught us about developer experience, or let's call it the story of my life in the last year. Yes, my name is Thomas Schuetz. I'm a senior enterprise architect at an Austrian job portal called karriere.at. Just out of curiosity, whom of you is from Austria? Okay, a few. So I think almost everyone who was looking for a job in Austria knows karriere.at. I'm not sure how this is in Germany. Yes, I'm there as an enterprise architect. Furthermore, I'm a lecturer at the University of Applied Sciences in Austria, also cloud native trainer, also CNCF ambassador, and open source contributor. Let's jump in. So at the moment at karriere.at, we are going through our cloud native transformation, as I think many companies are. And just to draw a picture, at the beginning, we had only an on-premise infrastructure. And the application we have there, or our portal, is built in a very monolithic way. And this has been extended over the last 20 years, and developers can work without intervention. So they can simply add new services, add new endpoints, or whatever, without asking someone. So everything around this monolith is auto-generated. Many comfort features are available. When they are opening up a feature branch, they get a deployment for it. And until now, they have no infrastructure responsibilities. So I think this is a story almost everybody of you know. So we started going cloud native, and yes, why did we do it? So, and I think this is the same old story as we know it from everywhere. So we are moving towards microservices to get faster, to get more flexible. Also to reduce the operational overhead. So you can imagine we at karriere.at, we are operating this portal. We have around 3.5 million visitors per month, but only 2.5 DevOps guys. So works pretty well for that. But we also want to get more efficient and want to distribute the load a bit. And yes, we want to improve the developer experience. I think this is also a story everybody knows. So if you are going throughout such a transformation or such a migration, let's say it this way, you have many expectations to developers. So they should deal with security, they should deal with secrets, also with API design, resilience. They should create their own CI pipelines, should know what GitOps is, should also monitor their services. And just as a side note on the left lower side, yes, and you are responsible for the service, and if it breaks on 2 o'clock in the evening, yes, you are responsible. Good. On the other hand, what do developers get? Yes, they get Kubernetes and lots of technologies which are making their daily work harder, right? So initially, when you are going throughout to Kubernetes and say to developers, yes, develop your services, put them on a Kubernetes cluster, in the most cases, they will have no clue. And while dealing with this, yes, it gets better, but in the end, they will not provide any value through this. So how does such a cloud native journey start? So initially, often people are tackling this from a technical point of view. So at first, you get cloud accounts, you are building your cloud foundations, landing zones, or however they are called. You install one or more Kubernetes cluster, build your delivery flow, sometimes with customized, sometimes with Helm, sometimes with completely different things. And yes, in the end, you create the deployment templates to deploy your services. And maybe throughout all of this time, you try to get rid of some legacy mechanisms. So over time, you will have some technical debt out there. You will think that this is technical debt. Sometimes developers see it in a different way. And maybe you as a platform engineer and so on want to get rid of this. Good. What's the result out of this? And I know that's pretty small, but you don't. I think it should only give you an idea of how long such manifests could get. This was one of our first approaches on getting services on Kubernetes clusters. So we were working with Customize. We had a base manifest. You see it on the left side. We packed in. This was more or less built on the Open Application Model and Kubela, and this got really long. And the other idea was, yes, we have a very short overlay, more or less, which can replace stuff and can make it easy for developers. The interesting part in this case was the base manifest was also part of a GitOps repository, which was in the responsibility of developers. So they had to update it, they had to maintain it, and whatever. Yes, and the overlay too for each environment. Good. What do we have to consider when we are working with this? So when we are dealing with such a base manifest, this is used in dev, staging, and production. So this is a base which can be used everywhere. We have on the right side, and it's still very small, you have a list of customized substitutions. So you will change environment variables, you will change some configurations, and so on. And the small part here is the environment variable your developer will like to change. Let's think this through a bit. So we have substitutions on the right side. We have an environment variable here. Maybe this is not depicted somewhere there. He adds something on the left side because it was not there already. So it's changed on all environments, right? So on the other side, a developer cannot be. So it's if he or she didn't write it, it's not simply possible to know where to change it. So some things we learn throughout of this. It's not a question if a developer will add or change some configuration. Developers will change the configuration. It's only a matter of time. The second thing is, until now, so we are working with PHP. They changed an environment file, simply in the environment, key value pairs, everything perfectly fine. I think this got a bit larger now. Until now, they have to create these YAML files, so they are fully responsible and understand the structure some platform engineer gave them. Last but not least, and we should always remember, now they are responsible for the service. So if something breaks on the left side of the story, and it has potential to break in production in this case, then they are responsible, not the platform engineer who created the template. Good. So how could a developer-friendly configuration look like? And some of you might find out that on the left side, this is more or less a values file of a Helm chart, which is not always developer-friendly, to be honest, but it's working pretty fine. We found out that, yes, the configuration should be easy to understand. So the developer-facing part of the story here is not very long if you think about it. So yes, we have a service name in there. So we are using a Helm chart for each and every, which is as a template for each and every service, which can be seen however you like. The cool thing is, if we change it on one side, yes, we can simply roll it out to all of our services. This makes things easy to configure. So if in this case, we are also configuring Kafka topics via this, you can add a Kafka topic there. You can say, yes, I want to create a service account. We give the people the possibility to change whatever they like. But they get some opinionated defaults, which will make it very easy for them to get up to speed. With this, yes, you have to think about the developer experience. So in this case, it's not a good idea to think about what can I leave out. It's only about, yes, what do the developers need? And how much of all of this stuff am I able to template? Last but not least, and this was a learning we had, we templated lots of environment variables out of this. So in the Laravel framework and so on, you need lots of environment variables to get all of this working. We created some defaults. And if you are thinking about such defaults and create such defaults, yes, document them somewhere and make them accessible to the developers. Good. So with this, and this was one of the starting points for us, where we said, yes, we want to approach the whole problem of platform engineering. And I think we never said the word platform engineering at our company. We built a developer-centric approach to cloud native. So I think many companies and so on think that platform engineering or building cloud native platforms is a technical problem. In fact, it isn't, because Kubernetes is more or less standard nowadays, I think so, at least. You can build the whole foundation in a very simple way. So I think deploying Cert Manager, Argo, whatever you need to get all of this running is not rocket science. But in the end, where it gets really hard and where people can bring, where the game is won or lost, is when it comes to how fast do I get my applications to production and how happy are my developers with it. So last year, I know this game is very old, but last year I started playing City Skylines. And while creating this talk, I thought, isn't it a bit like this game? So for those who don't know it, I think SimCity is more known. Your citizens won't react the way you expect them to. So yes, you can build a city, you can build roads, you can do whatever. But yes, if you don't think about water and so on, either they won't come or they won't stay, or they will be unhappy. Furthermore, think about the platform should serve the needs of your citizens, not the other way around. So while building platforms and while designing things around all of this, always have the people in mind who are creating the services on top of them. And yes, it's pretty cool if you use Argo CD, it's pretty cool if you use all of these fancy things running around, but if the people who are working with it are not happy with it, they will find ways to make themselves happy. Last but not least, if citizens will come from on their own, if you build a nice environment for them. So if you do everything to build a platform which fulfills their need, they also will be happy to work with it. So starting with all of this, you should ask yourself, what do your citizens really need? So in fact, every service you have can be seen as a residential area or a commercial zone on its own. So at the beginning, which connections will you need to the outside, and what does the service on its own need? So does it need a message bus? Does it have HTTP endpoints? Does it use gRPC or whatever? I will come back to that later a bit. These are things you should keep in mind from the beginning. Furthermore, how many parks should you build? So which funny things around all of this can you build to get the people on the platform, to make them talk to each other and whatever? Then what's their taxation level? So what do they need to get to the platform? So do they have to be a CKD? Do they have to know about Helm or whatever? So what do they have to bring to get there? How can I, by myself, ensure the health of my citizens? So how can I ensure that everything stays updated, that everything stays on a current level, and how do I get updates in there? And last but not least, how do I ensure that my citizens can live a happy life there, so that it's very easy for them to work with all of this? What I started at the beginning of all of this, and yes, it's the next picture, which is not really readable, but I started drawing how a service for us should look like. So the whole box, what you see here, is one PHP service from karriere.at. And this consists about HTTP endpoints. This consists about all of the interfaces you need to the outside world. Is it for session storage? Is it for relational databases? Is it for message bus? And on the lower side of side of this picture, we see all of these interfaces, all of the platform things we need there. So yes, we need a secret manager as everyone. We need a Cloud SQL. We are in GCP. We have Redis. We have an open telemetry collector somewhere. But by decomposing such things and by having a clear view on how your service looks like, it makes it pretty easy to build a platform for it. But also, if you took a look on the picture before, this can cause a bit of cognitive overload for developers. So building such a service, and let's go back, we have lots of technologies in there. Everybody has to be a Kafka specialist. Everybody has to know about how to write open API specs. Everybody knows to run GitOps and whatever. This can get really hard for developers in the end. So you as architects or platform team, you might have built POCs or prototypes. And one thing I can clearly state on this to this part, this isn't the real world. So yes, you have built a prototype. You will move things to the teams, but in the end, it won't work. At least not as they expected. Furthermore, if you went this way and so on, at the beginning, developers will be busy building the foundation, but they will not create value. So we had the issue that people had to implement authorization, they had to implement Kafka streaming at the beginning, and so on. Building value was the smallest part of the service in the end. And also, last but not least, think about the first page I showed you with the on-premise environment. They had a nice environment before. Now everything is simply complicated. Good. And also with this, I had a working thesis for all of this. So as a developer, I want to define my services in a very simple way so that I can focus on creating fancy things. I need to understand the platform, so I need to know that I'm working on Kubernetes and sometimes a bit about the behavior of it. But in fact, I don't have to be a CKAD to deploy my application. And this was always the thesis on which we worked on all of this. So yes, this is a residential commercial area and so on in city skyline. So what did we do to get to a pretty easy experience there? So yes, we defined some blueprints for areas. So I know that often people end up by building templates and end up by building automation. We started with this because we thought we wanted to get a service working from 0 in around 5 minutes. So the working thesis was we want to get a service deployed in development in less than 5 minutes, which has lots of implications if you think about it. So maybe you saw it before. We need a relational database. We need Kafka topics. We need yes, we need all of the things around it. We need monitoring and so on. And this requires a certain level of automation around it. So the first question we had was, what can we automate? What can we automate now, and what should we automate in 1 sprint, in 2 sprints, in a month, or whatever? But this by itself makes it really easy for you to find out what is needed to get there. So if you have a manual step in there, you have lost. Yes, I talked about the goals and requirements, but also databases, message brokers, and so on should be part of the blueprint. And surprisingly, we found a tool which can do it. And yes, I also often say people shouldn't start with Backstage. In this case, it was pretty easy for me to get Backstage inside of the company because it was already there. But also for a very funny use case. So initially, Backstage was there to host API specifications. So people could take a look on which services are there and just to find API specifications. And the only thing I had to do was to improve it in a way to say, yes, I create the first small template, then the template gets larger. And in the end, yes, people at the moment, people are using it to get their services up and running. The cool thing about Backstage is that it can open merge requests. So we are bootstrapping their Git repositories with it, but they also get a merge request to bootstrap it on their GitOps repository, so on their respective GitOps repository. Therefore, if all of the prerequisites are met, they need around 5 minutes to get it working. And so it's a pretty cool experience for the developers, and they don't have to deal with some Kubernetes stuff. Good. Another thing we thought about was, yes, people shouldn't be CKADs, but they should know about the platform and all of the things we have around it if they want. And in karriere.at, we have such a format which is called the Educational Thursday, where we can do trainings inside of the company, where we can talk about new topics and so on. And we created a series of such trainings to get developers on board. And at the moment in this class, we have 12 to 14 people. The course was booked out after 1 hour. And we are thinking about doing the next thing in October. So this also makes our life in the meanwhile a bit easier because they know to some extent where to find environment variables, where to take a look on logs, and so on. So if someone who attended these courses asks us where to find logs, we say, you learned it, right? And if he or she still doesn't know it, yes, he or she gets some guidance. Good, but this wasn't everything. So I said at the beginning, so platform engineering isn't always a technical thing, but it's also not only an infrastructure thing. So in the end, it's about the application. So interfaces into your services and so on can get very important. At the beginning, we found out, so we decided if a deployment was successful or not by taking a look if a Kubernetes pod in a certain version is up and running. Has its pitfalls to some extent. In the end, we added some endpoints on the services to get the state from inside of the application and checked on this thing, decided on these things if everything is running perfectly fine. So furthermore, you have to ensure that everything your service should expose, such as metrics, such as version informations and so on, is really well maintained, secured, and reachable. So we also dealt with things that we are exposing information from services, but what about security, right? So even our really small version endpoint gets larger in the meanwhile because we need authentication, we need authorization, and our mechanisms around this also have to check if everything is working. Furthermore, build standards and contracts in your company or in your team to ensure that your citizens can rely on your service. So we also established an ADR process for all of this. And if we find out that we have significant decisions or things we need to standardize across the company, we create an ADR, vote for it, and in the end, everybody is implementing it. Good. And as this is not enough, I talked a bit about prototypes and POCs before, and said, yes, this is not the real world. But what helped us a lot was we had a lighthouse project. So we took one project which should show all of the fancy things you can do with cloud native stuff. And we are a team of developers, architects, and platform engineers who are actively tackling things nobody wants to talk about. So one of the first things we tried to find out is how can we make the bootstrapping of a service itself a bit more comfortable. So it was not only about the technical part, it was not only about Kubernetes, but we went to a path where we said, yes, we want to have an open API spec, put it inside, and we get a really simple service in there. Furthermore, it was about monitoring, it was about observability. And what was very cool about this was that we also introduced such things as public reviews for this. So we said, yes, we as a small team are creating things. They will be pretty cool, and they will be relevant for each and everyone in the engineering company. So every two weeks we sit together, show the people what we are doing here, but also get feedback from them and also talk to them if they think that if they have concerns or whatever. Good. So I'm almost at the end of the talk. What was the learnings for us? So at first, developers are used to a certain way of working. So they know if I open up a branch or if I open up a merge request, I get a deployment somewhere. Furthermore, always have in mind their on-premise experience has evolved over the years and you can't change it from one day to another. They love the comfort your traditional stack provides, and yes, to repeat a bit, they were used to have DevOps guys and so on behind them who will help them. In the end, now they have to help themselves. If you make it too hard for them, the acceptance will be low, and we know how this can work in a GitOps environment. They can find their own ways, they can build their own platform, they can do whatever they want. If you are removing familiar features for them, this won't make the lives of the this won't only make the lives of the developers harder, but also the lives of the platform engineering team and the other ones. And last but not least, think about your current development flow and how to improve things, but not intentionally about how to remove them. Except the only exception is if developers are thinking that all of this is a mess, then yes, you can remove it. Okay, so for you, as a recap, you are building a platform for your developers and your services, not for the infrastructure. You should build a foundation which is easy to use, but flexible enough to adapt to your needs, as I showed it in the Helm chart before. And make sure that your developers can focus on creating value, not on the platform. So even if you don't have so much DevOps guys, add DevOps guys to the story. Let them put all the stones out of the way. And yes, create a community around your platform to share knowledge and experience. And with this, I think I'm already over time. I think there's not really time for questions, but I'm there today and tomorrow. So if you have if you want to talk about such things, find me somewhere on the outside. With this, I want to thank you and have a nice conference.